the previous lecture, we have looked at location selection problem and various methods of performing this location selection. Basically, the location selection problem is a very important one for any business. It has it wants to enter into a country or into a state, and it wants to start its business, and it wants to select the location. And then this location need not have to be for factories. It can be for warehouses. It can be for call centers and so on. So the issue, as we mentioned before, the idea is to be nearer to the markets, nearer to the suppliers, and also it should be economical, and ultimately the business should make money. So what we are going to do now is to look at the ecosystem aware location analysis. The ecosystem, that supply chain ecosystem, in our view, is the best way, or is the way of doing the location selection. In the previous methodologies that we have identified, this is location dependent. In other words, they are country dependent irrespective of the vertical. They may be indirectly taken into account, but not directly. So here, in this particular case, we are going to look at the supply chain ecosystem based hierarchical structure. Let's look at what we do. The drivers for supply chain competitiveness. If you were given a vertical, what are the drivers? Resources, labor, materials, and energy. The talent, managers, researchers, engineers, and production workers, availability and cost of materials, energy, and finance, and connectivity, infrastructure, ports, roads, and so on, and SES and clusters. So these are basically the resources that are important. And the government policies and investments and institutional environment and infrastructure elements. So the economic, trade, financial, and tax systems, the legal and regulatory framework, the investments and manufacturing software and innovation, and that is about the government, and delivery mechanisms, logistics and IT, B2B logistics players, trade facilitation, software costs, distribution centers, special economic zones, sensors, cloud, software for planning and execution, and all that. So if you look at the drivers of any supply chain competitiveness, these are also called the investment climate. So what we did here is we have said what are the drivers for competitiveness, or the so-called parameters, investment climate, whatever you want to call it. There are resources, government policies, and delivery mechanisms. Now we have subdivided the resources into human resources, the materials, energy, finance, and so on, and also the information structures, clusters, and so on. So that is how we have divided. And we have also divided the government policies into economic, trade, financial, and tax systems, the legal and regulatory framework, and so on, and the delivery mechanisms into this. So if you, by looking at this, what you are trying to do is the ecosystem, supply chain ecosystem which converts. Now, one thing that is important is depending on the supply chain you have, these things are different. In other words, if you are talking of an auto cluster, then the kind of delivery mechanisms that you need are different from if you are considering oil and gas and vertical, or an electronic vertical. So, for example, if you look at any of these reports of consultants and so on, you will have all or some of these factors, and they call it business competitiveness under various kinds of names that they do. Now, so this is a figure that we always consider in terms of supply chain ecosystem. You have the supply chain resources, institutions, and delivery mechanisms. So in the previous slide, we have seen that these also are the same things that each of this. So these three are called the investment climate, These are called the investment climate, and these are important for the co-evolution of the innovations, and also conflict resolution, and also for risk propagation. So since they also propagate the risk, you have to be careful to mitigate the risk, because the propagators of the risk are the ones that have to be addressed for mitigating the risk. So this is where that the ecosystem framework not only gives a place for location of the place, it also gives the risks that are possibly the supply chain is going to face, or any of the part of the supply chain that it is going to face, and how do you want to mitigate that risk. It is also possible that you want to innovate using this, and how to co-evolve with the innovation. So in other words, whatever part that your supply chain is making, how do you make it successful, and what are the co-evolution factors in terms of resources, institutions, and other things that are needed for when you are making the particular product. If you are making a product like which is a cheap computer or a tablet and so on, if you want to import it, or if you want to send it to other states, what are the kinds of government regulations that are needed to be this one, and how do you deliver those kind of things, and so on. So it becomes very important that you look at all these factors, not only from the location perspective, but from the perspective of innovation, possible innovations, because nothing is constant, everything is changing. There are disruptive technologies coming out every day in all the verticals. So in the presence of that, when your location, it should be possible to look at not only the location advantages of today, but also of tomorrow's innovations, and also possible risks. Whether the risk, if you are locating at a place, is it a natural disaster place? Is it a place where there are earthquakes? Is it a place where there could be thunderstorms which will disrupt the delivery? Or is it a place where there are frequent labor strikes? So you should look at all this and try to mitigate them, or be prepared, or be risk aware. So that's what the ecosystem framework gives you in this. So it is not just a static problem of location selection. It includes the dynamics of tomorrow's innovations, and also mitigating the risks that the system may face from whatever source. So this is the thing. You have the business value chain, which are the suppliers, agglomeration, economies, clusters, markets, and demands, and so on. And you have human resources, utilities, financial resources, and management services. These are the kinds of resources that you require. And you also have the delivery, like transport infrastructure, delivery infrastructure, logistics parks, service providers. These are all the people that are needed for this, and the institutions. So the issue here is that once you have you try to locate yourself, what is needed is in the business value chain. You are looking at your suppliers, market demand, agglomeration of business clusters. These become an important factor in selecting this. Of course, it's possible that you could put them under resources. The industry clusters are also under resources. So whatever it is, it's important to consider these particular factors in this. So it provides a generic framework for location selection. Provides a generic framework that can be used by the decision maker for location selection problem in global supply chains, irrespective of the industry and the type of investments. The parameters that we select, this is a generic framework. If you are talking of auto, you choose the corresponding talent, your corresponding financial requirements, the corresponding delivery mechanisms, the corresponding rules and regulations, and so on. So, but it is like filling the blanks within this. This is the kind of framework that these are all the issues that you need to address, and depending on the kind of vertical you are talking or the industry you are talking, then you can fill in those particular blanks. And every location problem is unique in the requirements of the investing firm and the intended business activity. However, they all share the SES characteristics. In other words, if you are talking of any investment, any business location, that it is unique in itself, because once you make an investment and enter a business in one place, it's very difficult to change. But you can always change it, but at a tremendous amount of loss. So what we have here is a kind of framework that basically a generic framework with the supply chain ecosystem parameters, which are the resources, the institutions, and delivery mechanisms. Once you select the corresponding vertical based parameters for all these three, then you can determine the location and its effectiveness. So what is the framework here? Only a part of the supply chain, such as a manufacturer, assembler, or a critical part supplier, may be interested in the location problem. Well, it is seldom that the entire supply chain is located at one place. As we said always, that the supply chain is global. Various parts of the supply chain is located in various parts. So if you are a manufacturer, you wanted to locate yourself in China or India or something, or you are a contract manufacturer, you are looking for a location, then you need connections with other players. In other words, you need to connect yourself with the suppliers somewhere, maybe in some other country, and the logistics providers both in this country and another country, and also with the upstream people like the dealers or the retailers and so on. So connectivity to the rest of the chain, both backwards and forwards, agglomeration economies, and adopting local markets, creating new business opportunities are important issues. So within this one that you are doing, you should have agglomeration of economies. You should be within a cluster so that you minimize the costs associated with that part of the supply chain that you are interested in that location. Also, you should have both the connectivity for goods transfer, for information transfer, and for funds transfer with your other partners of the supply chain, both upstream and downstream. And the supply chain is also affected by resources, both government, social institutions, and the delivery services for goods, information, and funds in all partner locations. So what is the SES model? The three fundamental criteria for SES model are integral to many global investments and hence can be used for varying decisions like locating manufacturing facility, warehouses, call centers, and R&D facilities. It is top-down approach by starting with the fundamental criteria first, then identifying suitable sub-criteria and attributes. And it is a product or vertical dependent. So basically this is the point. In the SES model, it is product or vertically dependent. So let's look at what are the factors that are affecting this one. So you can see in terms of the resources, the fundamental criteria are the resources, the institutions, and delivery mechanisms. These are called the fundamental criteria. And the sub-criteria within the fundamental criteria are human resources, financial resources, utilities, management resources, and clusters. Now, if you are assigning scores to each of them, human resources, financial resources, utilities, and so on, then depending on, supposing you have a place A, and in that place you give scores to all this, and then you can get the resources score for A. And if you take a place B, then the scores could be different. It may not have the power, it may not have the universities, it may not have the human resources that are English speaking or whatever. So, depending on that, what happens is the scores for the various places in terms of resources is going to be different. And similarly, institutions, the economic policies, for example, some of the countries have low income tax, corporate taxes, and some of the ports in some countries have very good trade facilitation. Now, for example, it takes only 8 hours to transfer goods in Singapore, whereas it may take 8 days in some other places. So, the laws and regulations are different, financial processes are different, political factors are different, and living conditions are different. So, if you are now taking A and B, you give scores for each of them. These are all sub-criteria. You give scores for each of them and have a way of combining all these scores into scores for institutions. So, for A, you have a score, for B, you have a score, which is an added up of this in some fashion. And similarly, for the delivery services, you have transport, information and communication technologies, customs clearance, and quality tracking systems. So, similarly, for A and B, you can give scores for each of these, and you can combine them and basically say that this is the delivery score. Now, you have a place A, and you have scores for resources, you have scores for institutions, you have scores for delivery services. You can have a weighted average of this. You have for place B a weighted average of this, and you can choose whichever is greater or less depending on what your criterion is. So, the point here is that these are the investment climate, this one for any place for a supply chain. Now, depending on the vertical, you write down what are all these sub-criteria. Now, if you are in biotech, which we are going to consider this one, the human resources should not be skilled resources, there should be researchers with PhDs. And similarly, if you are talking of auto industry, you don't need PhDs, you are talking of human resources which are skilled by for this one. So, and also if you are in auto industry, the financial resources should be for letter of credit and so on. But on the other hand, if you are in biotech R&D, the letter of industry, the financial resources should be in terms of venture capital and so on. So, depending on the vertical, for the same these things, these are different. But when you are talking about biotech, for example, and in 2 places, so the kind of resources that you have, you can basically order them, give scores to this and get a final score for the places and add them up for the scores for all this. That is going to be give you the best place, rank order the various places. I mean, very simply, this is the technique that is being used in AHP or some other thing. Whenever you have multiple attributes like this, and there should be a way of combining all this into this and combining all this into a rank. So that is what is being done here for the supply chain here for when we use the AHP. So what are the advantage of using AHP? The SES model is complete in the sense it covers all the forces that influence a global supply chain and takes an end-to-end view of the global investment. So you are talking of an end-to-end view from production, the resources and the delivery. It provides all the factors that are needed for location selection. More importantly, it provides organizations that influence the factors. Now, for example, if you look at the kind of changes that may come in the resources or the kind of changes in the government and so on, supposing there are high tariffs, who is responsible for changing the tariffs? Central government. Is it going to change or is it not going to change? You know, there could be some companies who may enter into the country thinking that there will be changes, and the changes may never come. One of the changes that people were expecting is the APMC Act in the food supply chain case, but that was never taken off. So similarly, people may expect things to happen, or the governments may process, but it may not happen. And similarly, the labor productivity in terms of this one, technological enablement and the logistics which is in the hands of the private players. There are several things that people may promise, but if you try and locate yourself in a place thinking that the improvements will happen, and if they don't happen, then you are taking a risk. And also here you get, for example, each of these cases, if you want to improve logistics in the area of private logistics providers, and you can have a deal with them, but you may not be able to influence the state government or the central government. And particularly if your improvements are like infrastructure improvement or changes of laws and so on, those are it is highly risky to assume that they will be changed in your favor. Now, for example, the Golden Quadrilateral linking all the major cities in the north, south, the east and west in India, it was supposed to be completed in 2012, but it has not yet. So these kind of infrastructure projects may take a lot of time. They have a lot of the cost and time overheads. So how can you use the SES framework for location selection? So there's two stages. For example, we'll take a case study, a location of biotech R&D in India, and the location selection is, for example, we selected 3 countries, China, India and Singapore, and the subnational location within India, Bangalore, Hyderabad, Pune, Chennai and Lucknow and so on. So let's see how to do this. So we use the analytical hierarchy process. It is called AHP, founded by Sati in 1970. It's a popular and widely used method for multi-criteria decision making. This is whenever you have multiple criteria to characterize a particular item. In our case, it is the location of the place, and you have multiple criteria like resources, like government regulations and delivery mechanisms depending on that, and each of them have several parameters. So how do you use, AHP is used for this. It allows use of qualitative as well as quantitative criteria in evaluation. In other words, some of these things can be in terms of numbers. For example, taxes or tariffs. These can be in terms of numbers. But if you say how good is the infrastructure, maybe you can say very good, good, low quality and so on. So basically sometimes you can give qualitative information, sometimes quantitative. And wide range of applications exist. For example, it can be selecting a car for purchasing, it can be deciding the place for your business, whatever. There are several applications that have been this one and the analytical. And by the way, this particular, after Sati has written this, the number of, if you type AHP, analytical hierarchy process, there you get thousands and thousands of papers with lots of applications in this. So the only reason why this became very popular, although it looks heuristic, is that it's a systematic method of combining both qualitative and quantitative measures for multi-criteria decision making. If you are using optimization methods, then it becomes highly complex, and sometimes the solutions may not exist. So if you look at AHP, develop a hierarchy of decision criteria and define alternative courses of action. And AHP algorithm basically composed of two steps, that is, determine the relative weights of decision criteria and determine the relative rankings of the alternatives. And both quantitative and qualitative information can be compared by using informed judgments to derive weights and priorities. As I said before, you assign the weights and priorities to each of these sub-items and combine them. So when we are talking of weights, the scale is, if the two factors contribute equally to an objective, then you call them 1. And you give 3 weight for moderate importance. Experience and judgment strongly favor one factor over the other. And 5, essential or strong importance. Now, for example, if you are talking of biotech R&D, then a resource of PhDs is of fundamental importance. So that gets a score of 5 in terms. And if you are talking of an export-oriented business, then the rules and regulations and the delivery infrastructure become very important. So that will get a score of 5. So very strong importance, and activity is strongly favored and its dominance is demonstrated in practice, then it gets a 7. And 9 is extreme importance. The evidence of favoring one factor over another is of tile importance, highest importance in order of affirmation. So basically 2, 4, 6 and 8 are intermediate values when compromise is needed. It could be between 2 and 3. When you say it is true, it is between 1 and 3 if you want to. And if a factor F1 has one number assigned to it when compared to the factor F2, then F2 has the reciprocal value when compared to F1. I mean, that's obvious. In other words, if you have factors F1 and F2, if you say that for F1, some factor is of extreme importance and say 5, then in the reverse side it is 1 by 5. So AHP for location of biotech R&D labs in India. Let's look at this. So if we look at, for example, want to analyze the biotech supply chain, the SES model, we have to have the criteria as well as the sub-criteria. What are the fundamental criteria? Of course, the biotech service chain, which requires the laboratory, researchers, collaboration with universities, research centers, clinical trials, and rollout finally. And as I said before, the researchers and the laboratory equipment and so on become very important, and also some collaboration with other research centers, clinical trials. These are all, if you draw the service chain for a biotech service chain, it is once you have an idea, you start the research, and then you collaborate. Once you come with a product like a vaccine, then you have to go for clinical trials, and finally, after everything comes out good, then you have to roll it out as a product. So that's the service chain. But for doing this, what are the kinds of investment climate that you need? That's the point here. Institutions, incentives, subsidies, research grants, cost of living, quality of life, foreign direct investment, and foreign collaborations. Now, will the government allow foreign collaboration? Will the government allow foreign direct investment in health industry or and the pharma industry or in biotech? And is the cost of living okay in that city so that people can live? And what is the quality of life? What is the schooling for children? So these are all the factors that will affect the location for this. And of course, the resources is the education and research institutes, one industry concentration. If you are talking about biotech industry, then one industry concentration, inter-industry concentration, which is do you have a biotech industry? Do you have a pharmaceutical industry which is related? Do you have a food processing industry? These are all, some of these related with the same kind of issues, and clinical trials, legal and value added services, and so on. Finally, you have delivery infrastructure, which is the information delivery, which means internet, lab connections, and so on, and airport connectivity for people to travel. So one of the things that happens with the biotech is if there is the communication, if they are not co-located, the labs, then it's possible that the people may have to visit frequently. So the airport connectivity becomes important. So what is that we have here? We have for the biotech, this one, these are the institutions, resources, and delivery mechanisms. So, and these are our requirements kind of thing, because this is the biotech supply chain, that service chain that we have, and so on. So you assign scores to all this. Now, for example, if you want to say research score, you want to give China, India, or this one, what are the kind of score that you are going to give for various of these factors? And finally, add them up. So the local factors are greenfield. Supposing you are starting a greenfield for this one. What is crucial? Availability and cost of highly qualified labor. Availability of quality of universities and technological institutes. Proximity and quality of international airport. People say these are crucial. I mean, most of these things are coming from some kind of a literature survey which is available on the net in public domain. And very important are investment and technology grants, because you require the support from both from the industry as well as the government. Because ultimately, when you are talking of biotech R&D, it is going to be the welfare of the people, the products. So there are grants that can come from the government as well as in the pharmaceutical and other food processing industry. Availability of technology and science parks, that is the clusters. Quality of life, cost of living, and international schools. Because if you don't want to move, the qualified scientists may not want to move into an area which does not have school, because ultimately the family becomes important. So if you want to locate your greenfield lab in a place where there are no schools, people may not this one. Important as quality of local suppliers, customers, and competitors, corporate tax regime, income tax regime, and regulatory framework, and so on. Less important, quality of costs of telecommunication and energy, microeconomic profile, political stability, and so on. So basically what we are trying to do within the parameters of resources, institutions, and the delivery mechanisms, we are trying to make what are the crucial things, what are important things, what are very important things, what are less important things. So you can see the whole procedure of AHP is so qualitative that you start with the resources, with the investment climate, parameters and then have subparameters and have them placed like this. And once you have these local factors which are crucial, very important and all that, then you can give them scores which we have given as 1, 3, 5, 7, 9 or 2, 4, 6, 8 in between and so on. So depending on their crucial things. For example, if you are biotech, the availability and cost of high quality labor is basically very important. It gets a ranking of 5 or 7. Availability of qualified universities, it also gets a rank of 7 in terms of the resources. So if a place has these resources, these, or if place do not have this, that matters in terms of the location. So the 12 factors relevant to subnational location choice of R&D centers in this. So educational research institutes, own industry concentration, inter-industry concentration, collaboration with universities and research centers. And investment and technology grants, incentives and subsidies, legal and value-added services, network connectivity. And international airport connectivity, cost of living, quality of life, political support. These are the 12 factors that same thing. For example, we want to select a biotech lab based on resources, institutions and delivery, and Bangalore, Hyderabad, Chennai and Lucknow and so on. These are the alternatives. So that's what the selective selection that you need to do. Okay, this national location choice. For example, you want to like this one. I mean, you have the institutions, economic issues, intellectual property issues, and political stability, trade agreements, and economic issues, sales, growth potential, investment and incentives and subsidies and so on. And you have resources, you have the delivery infrastructure in this. These are important, become important for the country selection. Now, if you give scores for all this one, like we have got these parameters earlier, and add them up to all this and finally get to a score, then what you get is this. Now, for example, in the ranking of this, you have this is the, although these are connected, they are not connected. The value chain score is this for India. Institution score is this. Institution score is much best for Singapore in terms of biotech, whereas it is medium for India, and for China it is lower, most probably because of intellectual property issues. And similarly, in terms of resources, India has very good research, this one, and medium for China, and Singapore has lower in terms of the numbers. And you have the same thing in terms of the delivery mechanisms. By the way, the data is sort of oldish, but if you have new data, you can always use that and so on. So the overall, you can add these scores for the overall, you get this particular thing, and then you select India. Now, how did you get this delivery mechanism scores? We went to the delivery mechanisms, looked at the connectivity. You assigned scores for the connectivity between the laboratories, internet connectivity and so on, and also the international airport. Of course, all these places have international airports, that connectivity is there, but Singapore has very high connectivity in terms of the delivery mechanisms, which you can see here. So Singapore gains both in terms of the institutions as well as the delivery mechanisms, but in terms of the resources and the value chain, it gets lower. So, but anyway, these factors can change. The only thing is, this is only to illustrate the method. It's not, we are not here go on the rankings of this and so on, just to illustrate the method. If you take the current data and use these techniques, which are very, very common in AHP, this one, which you can get it in any book or in the web through examples, then it's very easy to get this. So for this, it is suffice it to say that we have selected India here. That's because of these various parameters. So what is the big point here? The big point is we have selected the resources, we have selected the institutions and delivery mechanisms. We have subdivided them into various subparameters. We have collected the data from the field regarding what is the availability and rank order them, given them a rank. And for each of them, and finally we added all of them, then got this. So that's what AHP is about, and you can go through the various this one, that. So once you have selected the country, the next thing is to select the locations of choice. For example, the locations that we have are Bangalore, Chennai, and ICSA Knowledge Park, Hyderabad, Lucknow Biotech Park, and International Biotech Park, Pune. And information sources are India Investment Center and National Council for Applied Economic Research reports and so on. So basically the kind of information you have, you may not be able to get for all these parameters of the ecosystem, but it's possible to get most of these parameters. So if you look at the subnational, this one, and look at the location, this one, that the institutions, incentives, subsidies, investment, technology grants, political stability, cost of living, quality of life. You are looking at a city, cost of living, quality of life, political stability, and so on, and also education and research institutes, legal and value added services, and delivery infrastructure, and so on. So basically you can see that these subnational institutes are the cities where these are located, are the ones that you are interested here. So you can give scores for each of them. Now, for example, you have in India in biotech, and in Singapore there is in India we have selected India, and now you are talking of Bangalore, Pune, Lucknow, and so on. So basically for each of them you can see the quality of life for each of them. And of course now you can see that for example, for Bangalore, it has high resources. That's because of the presence of the Indian Institute of Science and several other parks and IT infrastructure, and there's and also the Bangalore quality of life, the presence of the international schools, and the state government is good and supporting the research in this. And of course, as far as the international airport, Bangalore has an international airport, and the connectivity is not as good as Chennai, what it used to be, but in those it is now, it has a very good international airport and so on, Bangalore. So if you look at all this, then you will find that for example, Chennai has good institutions, because the Tamil Nadu government is supposed to be very good in terms of attracting industries and in terms of the land laws and so on, but in terms of the resources it suffers. See, the kind of resource that you require biotech or PhDs and high-tech researchers. So that's where I think the presence of Institute of Science and other research institutes helps Bangalore. And also Lucknow. Lucknow has a biotech R&D lab. The others suffer because of the lack of that. And also, for example, if you look at Lucknow in terms of delivery services, it suffers because of the lack of international airport facilities. So you have these subnational rankings and so on, and you get this. So I want to mention again, although these are connected, this is not a connected graph, but it is only these points that you have, and it is just to show that the values of this so on. So finally you end up selecting Bangalore. So we have the national selection, you select India, and then within India you select Bangalore. Of course, if you change the scores, which are sort of sometimes qualitative and subjective, then you may get the other things. But suffice it to say that here we are using the AHP method and the scoring methods of pairwise comparisons and so on, which are familiar in the AHP literature, to rank order the subnational things, and finally Bangalore comes on the top. So here you can see that the ranking of Bangalore is 0.303, and then next comes Lucknow, and next comes Pune, and next Chennai, and finally Hyderabad. It is surprising because the Hyderabad has ICICI Knowledge Park, but in spite of that it lacks on the other ones like the universities and also R&D labs, although it has good R&D labs. So anyway, I mean, suffice it to say that these are some scores. This is more a method of illustration of how to do things rather than the exact this one. So if you have available data for each of them, it's instructive to go ahead and use the AHP to rank order the places and finally select it and so on. So, I mean, one can use this for other applications like for improving the investment climate and market attractiveness. For example, how do you improve the investment climate? We know the investment climate for that particular vertical depends on the resources. It depends on the laws and so on, and also it depends on the delivery services. Now, what you could do is, if you want to improve the investment climate, you can change the laws, you can improve your trade facilitation, or you can start new universities to develop talent in a particular industry vertical. So you can improve the investment climate in some other. This is the advantage of having the SES framework. SES framework tells you where you should improve and who are the people to improve it. For example, if you talk of biotech industry, and the biotech industry requires PhDs, then who should improve this? The improvement needs to be done using by universities or R&D labs, because you require PhDs, you require well-trained researchers for your R&D center. So that's where the SES framework not only gives you the values today, but it will also tell you how to improve your investment climate. Identifying verticals for developing in a region. For example, you have the investment climate. Now, given the investment climate, what are the kinds of verticals you should have? You take Chennai with all the investment climate, with the port and all that. What are the kinds of verticals that it should be? It should nurture so that it uses these facilities, the resources, and so on, like auto and others, where they import, export, and developments and so on. Right? But on the other hand, if you take a city like Bangalore with education resources and all that, then probably R&D centers and research centers would be a good location here, and that's what is happening. And similarly, if you take Pune-Bombay highway and so on, because of the Bombay port and also the airport and the financial hub, Bombay being financial hub, it will attract industries which are compatible with those kind of resources and the investment climate. So you better look at the identifying verticals for developing and identify tier 2 cities and verticals. So one thing that places are doing is these tier 1 cities are getting crowded. People want to go to the tier 2 cities. And also the salaries in tier 1 cities are very high, whereas in tier 2 cities will be low. So for a variety of reasons, people want to develop tier 2 cities. So that also can be done. These are the other applications that you have. So to conclude, what we have here, we presented a decision framework for location evaluation from the perspective of an MNC multinational corporation that is searching for a location to invest in its subsidiary. That's what we started with, and there are many design issues that regarding the SEZs from the government perspective, developer perspective, and the MNC wanting to enter an SEZ. All these can be analyzed using our framework. So what we presented is a framework, and you can use it for several different directions. And if you want to go further with this, there are these papers, one by me and Kamesh, where we started this work, decision framework for location selection. It came in IEEE Automation Science and Engineering, and it was presented in 2007 in Scottsdale, Arizona. And there is a recent paper which will appear in International Journal of Production Research, and written just a few months back with Samvedi. So this, to suffice it to say that the location selection problem is a very important problem that is faced by industries, and the supply chain ecosystem framework that we have been talking about in all the previous lectures is extremely useful, and the generic framework for the location selection, let it be a component manufacturing or a contract manufacturing or a warehouse or a call center or whatever, depending on the some ecosystem parameters.